Hey everyone, welcome to the first problem of the 1400 and beyond Codeforces rating series. In this series, we'll bring out one video per week, and what we'll plan to do is we'll reach 1400 Codeforces rating and above. So, what we'll do is we have this Kartik's specialist sheet, and in every video, we'll try to solve one problem each. The problem for today will be challenging cliffs. So, let's get started. It's a pretty good problem. I would recommend you read it on your own. Let me give you a gist of what the problem says. So the problem says that you have an array of length n, and every element of the array represents the height of a hill. Now what you can do is you can rearrange this hills in such a way that when you move from the hills from left to right, your movement is as hard as possible. So what is hard? Moving uphill is hard. So since walking uphill or flat is harder than walking downhill, you need to make sure that when you move from left to right, you have the maximum number of hills such that this condition is true for the ith hill. Additionally, there is one more constraint that when you rearrange the hills, the first hill and the last hill, so the hills at the extremes, the absolute difference between their heights should be minimum possible. So when you're trying to juggle these two conditions, you need to ensure that this is the priority number one, while the movement from left to right is priority number two. You need to ensure that this thing is minimized. That is the first priority. So let's see an example. Let's take this example. You have a hill of height 4 and a hill of height 2, 1, 2. Yeah. So if you were to move rightwards in this is downhill, downhill, uphill. So here your hardness was 1, moving from left to right. Let's see if you can get better. So if the second constraint was not there, let's say this constraint wasn't there to minimize this particular thing, the difference in the height of the extreme hills, left and right, what would be the answer then? So most of you will be able to think that in that particular case, your answer is going to be sorting the array. So 1, 2, 2, and 4. Now you have uphill, flat hill, uphill, 3. So just by sorting the array, you get 3. But the condition that you need to minimize the difference in the heights of these two hills, that's not getting highlighted here. And that is your first priority. The hardness of this is second priority. So let's see how we can manage that as well. So for this particular sample, definitely the right ends should be 2 and 2, because then your difference in the absolute height of these two hills is minimized. That is now 0. 2 minus 2 is 0. And then for the remaining two, you can either have 4 and then 1, or you could have had 1 and then 4. So if you have 4 and 1, then this is uphill, this is a downhill, this is an uphill. So here the answer is 2. But if you had 1 and then 4, in that case, this is a downhill, this is uphill, and this is downhill. So here your uphill movement is only 1. This is not good. This is a better movement because hardness is 2 here. Similarly, for the last example, the hills are 3 and 1. This is a downhill movement, but if you keep it like this is uphill. And in both the conditions, your difference between the absolute difference between the heights is 2. So this is a better answer. So that's the problem statement. Take a while to think of some solutions. I would say, if not solutions, think of some observations. And now pause your video. I'll move to the observations that I made when I was trying to solve the problem and how we can reach the final solution. So the best possible answer is going to be n minus 1 no matter what, because your hardness depends upon your number of movements in the array, and since there are n elements, you can at most move n minus 1 times to the right starting from the first element. So your best possible answer is n minus 1. If there are just two hills, your answer will always be n minus 1, as we saw in the case of 1 and 3. You'll always move upwards. Just sort the array. Since there are just two elements, you'll always have the answer as 1, which is n minus 1 for n equal to 2. Also, if all the hills are identical, then also your answer is going to be n minus 1. Since everything is identical, you can just move flat hill, all good. Next observation is that when you sort the hills, it optimizes your uphill movement to n minus 1. But after sorting, there is a problem. If the hills are identical, of course, then there is no issue, all good. But if the hills are not identical, then there is a problem that the absolute difference between the first and the last element needs to be minimized after the sorting has been done. So let's think of ways to minimize that. Let's say you're able to find an I such that the difference between the ith and the I plus 1th hills is minimum possible. You can potentially move these two hills to the extremes. Let me give you an example here. So let's say I sorted my input hills, and I found out that the delta here was minimum. So these two hills have the least difference in their heights. Now one of them I can move to the starting. Maybe let's say I move this one. And this one maybe I can move to the end. So now what happens is this is a downhill. So is this, while the remaining are uphill. So I can definitely get an answer of, so these are n minus 2 hills in between. I can always have an answer of n minus 3 for sure. This is definite, very easy to do. Just find out where this particular I. And you can always get an answer n minus 3. You cannot get an answer n minus 1 unless all the hills are identical. That is also for sure, because let's say you have all n minus 1 hills as identical and only one hill which is not identical. So let's say this is your input array. Now, no matter what you do, you have to place the one of these two at the end. And that would mean that this particular hill will come somewhere in between of this array, which will cause you to go one downhill. So unless all the hills are identical, you cannot have the answer n minus 1. You can always have the answer n minus 3. Now the thing is, since n minus 1 is not possible, n minus 3 is always possible. Is there a possibility to make n minus 2? If I can construct n minus 2, then I'm good. It's the problem is solved there. Let's see. So two things I can do. Either I can prove that n minus 2 is not always possible, or I can prove that n minus 2 is always possible and then come up with a way to construct that. Let's first try to prove that n minus 2 is not possible by a counter example. So I just took this particular example where I'd found a delta and moved that to the left extreme, and then my array looked something like this. And finally a downhill. So downhill, uphill till the largest one, and then one downhill. The answer here was n minus 3. If I move this to the beginning, so all I need to do is keep moving as many to the beginning till you get an uphill here, at one downhill here, and all the remaining are uphills. This is possible in some cases. One of the cases is the example input. Let's move to the example input. 4, 2, 1, 2. After sorting, it looks like 1, 2, 2, and 4. Now you need to move these two to the extremes. When you do that, it becomes 2, 1, 4, and 2. Here the answer is again n minus 3 as we discussed above. N is 4 and the answer is 1. So downhill, uphill, downhill. But I can prove that n minus 2 can actually be constructed here as we saw in the sample output by simply changing these two. And then it becomes like a uphill, downhill, and an uphill. So n minus 2 is actually possible. So I could not prove that it's impossible to build n minus 2. So now there are two possibilities. Either it's always possible to build n minus 2, or it's sometime possible versus sometime not possible. Now I'll prove you that it's always possible to actually build n minus 2 by a diagrammatic example. So after sorting, let's say this is what my hills array looks like. Assume that the minimum delta is between these two. Okay. If the minimum delta is between these two, all these movements are uphill. Same way, all these movements are uphill. Given that these are n hills, let's say this is the ith one, you have n minus I hills in this region. This is a total of, in this region, you have a total of the right region I'm talking about. You have n minus I minus 1 uphills. Similarly, in the left region, you have I minus uphills. What happens now, given that this is good, all I need to do is this thing has to go to one of the extremes, either the left extreme or the right extreme. And again, this also has to go to one of the extremes, either the left extreme or the right extreme, to make sure that the two hills that have the minimum absolute difference are at the extreme ends. What I'll do is, since this has to go to one of the extreme, I'll take this entire thing and move it to the right of this thing. What happens is that this will become hill number 1 then, and this will become the nth hill, given that I keep it as it is and only move this region to the right. Now you will get one downhill from largest to this when you move to this one, but rest all are uphills. So how many uphills do you get if you simply take the right region, place it to the right of this left first half? You will get n minus I minus 1 plus I minus 1, which is equals to n, I and I will get cancelled and it will become n minus 2. So it's always possible to put n minus 2 as your answer. Now, if you're satisfied with the answer, that's great. Hit the like button. If not, let me know in the comments. I'll code the solution now. So I'll input t for the number of test cases. What's next? I think I have to input n now, the number of hills. Then I need to input the length of the hills. So let me take a vector. At the same time, what I can do is also calculate the min delta and the position for that min delta. Min delta, let's say 10.9. Initialize it to 10.9 should be good enough. Now I'll loop from the 0th element till the n minus 1th element to find where the min delta is. Basically, I'm looking for the I where I need to break the array into two halves and then take the first half and place it to the left of the second half. So 0 to n minus 1 and delta here equals to hill at I minus hill at I. Hill at I plus 1 minus hill at I. If this is less than the min delta, in that case, what I'll do is I'll set min delta equal to delta and then min pos equal to current pos. That's, I think, all. I just need to print the answer now. Printing would be the print the second half first. So from all the way from I plus 1 to n minus 1, and then print the other half or the first half. Actually from 0 to I. Right. So what I'm doing is printing from I plus 1, that is from here to the end, and then printing from 0th to ith. So ith is the last hill, I plus 1th hill is the first hill. And I think we should be good here. Let's try out on the sample input. Okay, wait. This will be the min delta pos, not I. Let's try out one sample input. So answer should be, wait, why did I not get any output here? T test cases, that's good. I input the array, then I go from 0 to n minus 1. Delta is fine, delta less than min delta. Okay, let's quickly debug what could have gone wrong here. Let's just comment this out. Oh, I'm not sorting the array, sorry. Okay, still nothing got printed, which is fine. So I take the min delta as 1e 9 plus 1. This should be fine. Then delta equal to hill I plus 1 minus hill at I. This should also be fine. Delta less than min delta. Okay, what happens when n equal to 2? Could that be the thing breaking it? Let's quickly look at it. Min delta pos is 1 minus 1. Then loop through from 0 to 1. Right. Actually 0 to 0. Check the delta as hill at 1 minus hill at 0, which would be 2. This is fine. Then for min delta pos plus 1, min delta pos was 0. 0 plus 1 is 1. Okay. Then 0 to min delta pos. Looks fine even in the case of n equal to 2 actually. Although I think that would be wrong. Let's quickly go through it. It's just for testing. No, still not working. Wow. Oh, got it. Again, sorry for this. I never declared the size of the vector. Yeah, 241, which is incorrect, and then finally nothing. So let's see what could go wrong. Min delta pos plus 1 to n. That should be okay. Then 0 to min delta pos plus 1 because the loop ends at min delta pos. 2412. And for the last case, when, yeah, let me get that input. Yeah, this is wrong because in the case of n equal to 2, you can always get the answer n minus 1 by just sorting the array. So all you need to do is do this if n equal to 2, just print the array after sorting. That's it. I will try submitting the solution. So guys, if you like the video, make sure that you like to the channel, subscribe to the subscribe to the channel and like the video. And I'll keep getting more videos. Let me know anything that you'd like to add in the comments. I hope this is going to be a very useful series for you to reach 1400 and above rating. So thanks for watching. Bye bye.